Assalamu alaikum, my dear students. Hope all of you are fine. This video is on the topic, which is 4.2 and 3 related to our electricity portion. This video is upon the request of my students. So here we are going to start it from the question. This figure shows part of the circuit of a hair dryer with a 240 volts AC supply. Here you will see that we have 240 volts supply is given to you, and this circuit is about the hair dryer which they are telling us. The switch can be in one of three positions, position A, B, and C. Position A is representing that the hair dryer is off. Position B is representing the low heater power, and position C is representing the high heater power. All three heaters XYZ. Dear students, this is the symbol of electric heater. So when they ask you in any of the other questions that what is the symbol of electric heater, so please draw a box and there should be three lines inside it. And this is representing the symbol of the electric heater. So here we have three heaters, X, Y, and Z. They are saying that all of them are having the power 1000, like each of them. X is also having the power equals to 1000 watt. Y is also having the power 1000 watt. And similarly, Z is also having the power equals to 1000 watt. So, and heaters Y and Z have equal resistances. This heater Y and Z, both of them, they are having equal resistances. So they are equal in number, right? The next part, what they are asking for us is that we have to calculate the resistance of heater X. Okay, so we need to calculate the resistance of this. To calculate the resistance, as you know, we have power of X, power which is equals to 1000 watt, and what else is given to us? That is the voltage which is applied across X, that is 240 volts. So the thing which we need to calculate is the resistance. So now by applying the formula, which is P is equals to V square over R, we are in a position to calculate the value of resistance. Just rearrange this formula. We are able to get the answer. V square means 240 square divided by 1000. When you will solve this, you will be able to get the answer, which is 57.6, or if you are going to round it off, your answer will be 58 ohms. The unit is very important for you to write, so please make sure after solving the question that you have mentioned the correct unit along with the answer. The next part is that resistance of heater Y. This question is of 1 mark. So resistance of heater Y, here did you notice that heater Y and Z, these two are in series with each other. So to calculate the resistance Y, we need the voltage across the Y resistance, and this is very important. In power, we know that what it is. As you know, this is 240 volts and these two are in series with each other. So V1 and V2, these two are, we need to calculate V1 and V2. As here it's mentioned that Y and Z have equal resistances. So it's very easy for us to divide this 240 volts into two halves because of equal resistances. If the resistances are not equal, then we are not in a position to divide it by 2. Okay, so across Y it should be 120 and here it should also be 120. You can just simply divide this 240 by 2, you will get 120 volts. Okay, so because you know in series the voltage will be added, like total voltage will be equals to V1 plus V2. It should be like this. So we just split it up into two portions to get our required answer. So here, what is the requirement? In this part, we need to calculate the resistance. Once again, we are using the same formula. that is V square over power. So V is 120 in this situation, and power is 1000. So when you will solve this question, you are able to get the answer, which is approximately equal to 14 ohms. Its resistance, as you know, the unit of resistance is ohm, so please don't forget to write the unit ohm here. The next part is the current in the heater Z when the switch is in position C. We will move back toward the diagram. Here you will see that this is the position C, and they want that we will calculate the current in heater Z. This is heater Z, and they want that you will calculate the current in it. As you know, once again, these two are in series with each other, so current will remain the same throughout this branch. We need the total voltage and total power to calculate the resistance. So if you and what else is needed? We have the formula power is equals to VI, and the current can be calculated with the help of that formula. Okay, so we should use the formula P is equals to VI. We have voltage, we have power. So total voltage over total power of that branch is needed to calculate the current. So total voltage is 240. Like initially, we should rearrange the formula. Give me a minute. It will be P over V. Power will be 2000 because there are two heaters in that branch, which are in series with each other. This is heater Y and this is heater Z. And to calculate the current, we need the total power of both of them. So you know that 1000 watt is for Y and 1000 watt is for Z. So we should add them up to get the total power. And across this branch, you know that in the power supply, it's mentioned that 240 volts is given. So divided by 240, you will be able to gain the answer. And that is around 8.3. Okay. So as we know that the unit of current is ampere, so please don't forget to put ampere here. Moving on toward the next question. A circuit consists of 12-volt battery, 3 resistors, and a switch. The battery consists of 2-volt cells in series. State the number of 2-volt cells in series in the battery. So, as you know that the total voltage of the battery or the total EMF is 12 volts. So you can just simply divide the total voltage over the voltage of a single cell. You will be able to get the number of cells. Here it's 6. And as you know that number does not have any unit, so there is no need to write the unit along with it. The combined resistance, next part is that we have to find the combined resistance of the two resistors which are in series with each other. So here you will see that 28 ohm and 20 ohm, these two are the resistors which are in series with each other. So to calculate its resistance, you know the formula total or combined resistance will be equals to R1 plus R2. So 28 plus 20 plus 20 will give you 48, and the resistance, the unit of the resistance is ohm. So answer will be 48 ohms. Now they want that we will calculate the total resistance of the whole circuit. To calculate the total resistance, there are you can use any of the formulas. Either you can use 1 over R is equals to 1 over R1 plus 1 over R2, or you can use the product of resistances over sum of resistances, because now we have parallel combination. How? Because you know that when we calculated the combined resistance of two of the resistors which are in series, we know that its answer is 48 ohms. And there is another resistor over there which is of 24 ohms. So we have these two resistors here which are in parallel with each other. So when you will use this formula to find its answer, we are just applying here 48 times 24 divided by 48 plus 24. So when you will solve, using the calculator, you are able to get the answer, which is 16 ohms. Okay, so 16 ohms is the answer for it. Next question. The switch is now closed. Calculate the current in 20 ohm resistor. 2 marks question. We will see where is the 20 ohm here. Okay, just right now we have, I told you that to calculate the branch current, we need the total voltage, total resistance in it. So I am just drawing this diagram here for your reference, that we have two resistors here which are in series with each other. One resistor, the value of one of the resistor is 20 ohm and another is 28. 20 ohms and here 28 ohms. And the value of the power, the value of the voltage which is given to us, that is 12 volts in this question. So here across this, you can say that 12 volts is given to you. So to calculate the current in this branch, you need the total voltage and total resistance. So V is equals to IR is the formula which we are using, and I will be equals to V R. R will be the total resistance. So voltage will be 12 and total resistance is 48 by adding these 20 plus 28. So after using the calculator, you can just figure out that the value of current is 0.25 and the unit is ampere. The next part is that you have to calculate the charge that flows through 20 ohm resistor in 6 minutes. So Q is equals to IT, and I, you know that we have just calculated, which is 0.25, and multiply by time. Time should be in seconds, but here it's in minutes, so it's very easy to convert it into seconds just by multiplying them with 60. So this is the time frame. So you can just take the product of these to get the answer, and your answer will be 90 coulomb. Next question. This figure shows a graph of current against potential difference for a filament lamp. State what happens to the resistance of the filament of lamp as the PD changes from 0 to 1 volts. If you will see, 1 volt is here. Okay, so starting from 0 till 1 volts, they are asking that here what is the effect on the resistance. So as it is a straight line and the graph is starting from origin, so these two conditions are fulfilled. It means that resistance will be constant here. So you can write that constant resistance. Constant resistance. Okay. The next is from 1 to 8 volt. You will see that starting from 1 till 8 volt, there is a curve. Okay. So here the curve is there, and you know this is the filament lamp. If we are keep on increasing the voltage, then the temperature keeps on increasing and resistance also increases. So in this case, you can say that resistance increases. Okay, so you can write resistance increases. At normal brightness, the PD across the lamp is 8 volts. Calculate for normal brightness the resistance of the lamp. To calculate the resistance, we need voltage and we need current. For reference, they give us the value of voltage and we can take the value of current from the graph. It will be easy for us. So you can see that this is the point of contact from 8 volt on the graph. And when you are moving from here to the other side, here it will be 0.70 at this point, and this is just one box ahead, so it will be 0.72. So the value which is needed to us is 0.72 at this box, 0.72. That is the value of current at 8 volts. So 0.72, when you will divide these two factors, like 8 divided by 0.72, so your answer will be approximately equal to 11 ohm, or maybe you will get 10 point something. So just and you will write 11 ohms for it. The power of the lamp. You need to calculate the power of the lamp also. So for calculating the power, you can use the formula P is equals to VI. P is equals to VI. So voltage is 8 and the current is 0.72. So the answer, after taking the product of these two, you will be able to get the answer, and that is 5.8 watt. 5.8. Okay. So the next part of this question is that 5 of these lamps operating at normal brightness are connected in parallel to a power supply. You should tell them what is the EMF of the power supply. With a normal brightness, they are saying that the voltage is 8 volts. So we will directly write here 8 volts because it's given, already given, that at normal brightness, the PD across the lamp is 8 volts. So all of them are in parallel with each other. So you know that if here it's 8, so every one of them will get the 8 volt battery at their normal brightness. Okay. So 8 volt will be the answer for this part of the question. Moving toward the next part of it, they are saying current from the power supply. If you want to calculate the current from the power supply, in one of the lamp, we will calculate it. We will see that the value of current is 0.72. That is for one lamp. You like here 0.72, and these are now 5 in numbers which are connected here, and they are of the same, like 5 of these lamps they're talking about, like they are identical. So it means that 0.72 is the current which is in each of the branch which is needed for all of the lamps. So it's very simple for you to calculate the value of current. Just simply multiply 5 with the value of current of the single current, because in the parallel combination, the value of current is splitted up. Okay, so it's divided. So your answer will be 3.6 ampere. Okay, 3.6 ampere. All right. So the resistance of a circuit component varies with the brightness of the light falling on its surface. State the name of the component. As you know that resistance is affected by the light, so that is the LDR, light dependent resistor. And the circuit symbol for this component will be a resistor, and it is depending on light, so arrows will be pointing toward it. This figure shows a 6-volt battery connected in series with 1.2 kilo ohm resistor and a thermistor. At a certain temperature, the resistance of the thermistor is 2.4 kilo ohms. Calculate the reading on the voltmeter. Okay, so we should calculate the reading on the voltmeter if the value of the thermistor at certain time will be 2.4 kilo. Okay. So we should calculate the reading here. Let's suppose this is V1, here it's V2. So if we want to calculate the voltage, so it will be V1 equals to IR. So the voltage across here will be 2.4 kilo ohms. I'm going to convert that into ohms. First of all, that is 2400 ohms. But we don't know the value of current, so we should calculate the value of current. As you know, these two are in series with each other, like 1.2 kilo ohm resistor and thermistor. So to find the value of current in series circuit, we need the total voltage and total resistance, right? Total voltage will be equals to 6, and it is given here. And the total resistance, that is the sum of these two resistors, 1.2 and 2.4. When you will add them up, you will get 3.6 kilo ohms, but we need to convert it into ohms, so it will be 3600, because to convert from kilo ohm to ohm, we should just multiply with 1000. So you can use this value here, the value of current, which we will just calculate it. Now, after solving this whole, what should be the answer? Like after solving this part, the value of voltage across 2.4 kilo ohm resistor will be 4 volts. It's equals to 4 volts. Okay, here it will be 4 volts. Let's suppose if they ask you to calculate V2, V1, now you have 4 volts across this, so it must be 2 volts. You can just take the difference between these two values, like 6 minus 4 will give you 2, because the sum of these two will be equals to each other as it is a series circuit. So 4 volts is the answer. The battery connected to the circuit in figure 9.1 is not changed. Okay, battery is not changed, so suggest a change that would cause the reading of the voltmeter to decrease. So uh, for this answer, you can just replace the 1.2 kilo ohm resistor with a higher value of it. Or second thing is you can increase the temperature across the thermistor. Okay, so if we need to decrease the value of voltage, we need to decrease the value of resistance, and the temperature should increase, because if temperature increases, the resistance across the thermistor decreases. Okay, so till here we have done 4 of the questions. Inshallah, in my next video I will solve more questions on it. So please practice these questions. I hope that it will be very easy for you to understand now these questions. Try more questions based on it. Take care. Bye.